Okay. So in this particular chapter, we have covered all the services, different kind of services, then how we access them and all those things earlier. How the Ingress work, now that the DNS works. And today we are going to jump into the Ingress part. So can please others mute? Yeah. Okay. So for the Ingress, so we talked about different kind of services, primarily cluster IP, node port, and the load balancer service. And we know that with load balancer service, we can expose our applications publicly and access them. With the node port also we can do, but we have to do it with the combination of the the node IP and the port number what we are going to use there. Now, so of course we cannot use the node port as it is because we cannot have a DNS name mapped to a combination of IP and the port. So we can use, of course, a load balancer type. But the point there is the underlying infra on which you are running that should support the type load balancer. So it can be either um, your cloud provider one, or within your company, within your environment, you can also set up something which serve the load balancers, and that also you can use there. Now, the problem that comes with that particular part is that first of all the cost. So if you are deploying the load balancers on the cloud, then of course you have to pay for the load balancer in most cases. And then, of course, the type load balancer type does not work in all the cases. Like, for example, we have these different microservices based endpoints. So we cannot just use the load balancer to serve different services endpoints like slash ABC slash payment slash gateway and all those things. And of course, the more LBs you will create, the more you have to pay. So that is the point that we should not be using the type load balancer too much, and that is where the ingress picture. So with the ingress, what we can do is we can have in most cases one load balancer type, and that can serve all the incoming requests for us. So just highlight how many of you have configured Ingress earlier, right? Have you configured Ingress first of all and configure Ingress controller as well? So yeah, anyone has?
Yeah, I have Nginx Ingress controller.
Okay, great.
And I
Anyone
have,
else? Mhm.
yeah, I've worked with a couple of things, Nginx, Istio, ALB controllers.
Okay,
Yeah,
others?
there is Contour. It's from Cloud Native. I
Mhm.
lately tried it. It's a good one. It has a gateway, a load balancer type. Yeah, service gateway, which is load balancer type. Then you create multiple ingresses to your services, and they are mapped to this load balancer external IP.
Right, right. Yes, Contour I have not got a chance to work with, but while reading this book, I saw some of the capability of it, what it can do, which makes much better sense than others, to be honest. But I have not used. So I have primarily worked with the Ingress, the Nginx based, a bit on traffic, and then ALB. So that has been my primarily exposure to the Ingress there.
For
Okay,
Contour,
so
it uses Envoy proxy. Yeah.
okay. Yeah, so we'll talk about the Envoy today. So yeah, though I have used Envoy, yeah. So I have done one lab earlier with Envoy. I built one labs and then got a chance to explore Envoy a bit more in detail. I think that would we're going to talk about that today. So as we continue in the service mesh, we're going to explore the Envoy for sure. For others, typically what happens is as a developer, right, the developer creates these ingress objects, Like in this case, we are saying that, okay, there is a site called bookhotels.com, and whenever somebody hits that particular website, it will come to our Ingress and Ingress controller, and then it can serve the content from the hotel service. And similarly, for the flights is bookflights.com. So now all of these entries are coming to our Ingress controller, and that Ingress controller can handle these two websites for us. Now, this is the example of the uh, Ingress, you can say, as virtual hosting, in which we are doing different names here. We can also configure the fan out based Ingress, which I think has not been mentioned in this particular book. For example, in that case, I would like to say bookhotels.com slash my room, right? Or something like that, right? So you can say, uh, you can get different path based thing as well. So that you can consider as a fan out based method. So we have one domain name, and then we can have slash abc slash xyz and all those things that would become your path based routing. So that can be done. Now this is only the ingress object which the developers are going to create. There is going to be somebody who is going to make the eventual mapping, right? So currently this is, you are giving the guidance in a way to the Kubernetes cluster or the ingress controller there, saying that as a developer, when somebody hits this particular website, it should come here. But now, how would the actual network configuration, who would do it, right? For that purpose, we would be requiring the ingress controller. So this is what it is. So what you see here in this example is we have a cluster. On a given node, we are running something called as ingress controller pod. And now this controller pod has two components here. One is the controller container component, and then another is a proxy container. So now as a developer, when I create the ingress object, our ingress controller container, the controller what we have here, right? It would look at that event and then configure the proxy container like nginx something, which would basically eventually tell if that traffic is coming on this particular website. If I can see that, you have to connect, you have to patch it with the hotel's service endpoint. So that is the part is being done by this particular other container here. So hope this makes sense. And what you also see here is typically the controller part does not forward the traffic to the service. So though we are saying here, get it to the hotel service, but eventually it is going to patch us to the hotel's pods, whatever we have. So it basically bypasses that particular service layer, and that would make it much more faster because it can then connect to the underlying pods directly. Any questions here, guys, or any other points you want to highlight? Okay, fine. Okay, now what can happen is as the developers are creating these ingress objects, there can be some kind of conflict, right? Let's say if two different teams create the same ingress object with the same name, it can become a bit challenging. To overcome that, what was mentioned that we can take the help of admission controllers, and we can pick up a policy agent. That policy agent can guarantee saying that if ingress is already created, we don't create another one. So now what is this policy agent and admission controller, right? So as you know that, right, whenever a request is being sent to the API server, it goes through three stages: authentication, authorization, and admission control, right? At third stage, we can put some kind of rules we can do it on our own, and some of them comes from the Kubernetes itself. And to put our own rule, we use this policy engines or policy agents, you can say. The example here given is the example of OPA, which is a generic policy engine which can work other than Kubernetes as well. But then we have something called as Kyverno. Hope you guys heard about the name called Kyverno. Kyverno is another policy agent which can put some of these policies in the enforcing mode or just a warning mode as well. So we can have this policy configured in our cluster saying that if somebody else is trying to connect or create the same Ingress object, we kind of raise the flag. That was the point here. And then they mentioned another here, which is with the help of controlled Ingress controller. So the idea here is we are going to create the root resource, and under that we are going to have uh, some of other people are going to create further objects on that and so on. So as far as I understood is so we are going to kind of group these ingresses under one kind of a say, top level object, and that way the top level object always guarantees that there is a uniqueness within my configuration. Right? Hope I mentioned rightly. Yeah. Again, any other suggestions, comments on this? Okay. Now there has been one challenge with the Ingress creation. So what happens is, let's say when we have different kind of Ingress controllers uh, like Nginx, Traffic, and others, right? Now, if we have to kind of enable some kind of features in that, so for example, if you want to enable the feature of basic authentication as somebody access my website, correct? So you can put some kind of annotations based on the Ingress controller we have. So I assume that all of you know what annotations are. They are nothing but the objects by which we can add the properties to our objects. So what we can say that when I'm creating the Ingress object, add a given property. And all of these different Ingress controllers are going to have different properties. And for that purpose, we can add annotations. But these annotations can become a bit more challenging. First of all, as is pointed out already, right? There is no way the API server can cache the misconfiguration, right? Because there are different kind of annotations are there, whether they are right or wrong for a given Ingress controller. Only the controller would decide, not the API server, and that becomes a bit challenging to kind of manage that. So to overcome that, we can kind of leverage some kind of CRDs which can lock us into a given configuration, and then that would make our life much more easier. So that was the point. Here, this we already covered right now, the Ingress controller, proxy container, and so on. Okay, let me see other points what I have highlighted. Um, okay. So, has any of you have seen the Ingress controllers configuration file? Like once we are the Ingress controller, and what we are saying here is the proxy container, right? So basically, there's a controller and there's a proxy container, which is nothing but your Nginx, for example, in case of Nginx controller there, right? Now, have you seen this particular configuration file getting updated on the fly? So, for example, if I create new Ingress object, automatically this particular configuration file of this proxy container, think about Nginx configuration, that get changed on the fly. Have you guys explored that or not? Yes, no.
Nope. Could it be the same Nginx configuration file?
Yes, almost yes. More or less same. Yes, correct. The main point here is what will happen. What it will contain eventually is it would contain that if you have to access this particular website, you would go to such so and so pod endpoints, as simple as that. And of course, there are good more settings depending on rotation and so on, what you have. But the main thing is there. So, for example, today I have two pods running for my front end service, for example. And for those two pods, it has a mapping saying that bookflights.com would be accessed by these two pods. Now, what happens if I scale my front end now? And if I create now 5 of my front end pods, what is going to happen is this ingress configuration or this config of engines what I have there, right? It would be on the fly get reloaded and I would have 5 endpoints there. So basically, though we connect via service, but eventual endpoints are the pods. So as you scale your applications, those endpoints get created further, and this configuration file of Nginx get reconfigured on the fly for you. So whenever you get time, you can deploy the control of Nginx. You can then exec into the Nginx pod or the container what you have there and look at the config of nginx.conf. And that would give you the good great detail about how this is happening. And you can see that on the fly, as I scale my pods, the entry would come in automatically there. So it can reload itself on the fly. Yeah, give it a shot. Sometimes it will be very interesting exercise for you to kind of understand how things are happening.
Mr. Dibendra, I have a basic question. If you don't mind, can I
Yeah,
ask?
please go ahead. Please go ahead.
Yeah. Actually, no, I haven't worked with Ingress much onto it. Okay, but what I do have a test environment in WSL. Okay, and
In WSL, okay, okay, in your
yeah,
Windows, okay.
yeah, Windows, and within that I do have with Ubuntu. Okay.
Okay.
So my problem is like regarding this, no, this external IP. There is always I used to get a no issue with these IPs. Okay. So if possible, can you give me a highlight of how I can have the ingress within that environment? If anyone can share on this.
So you are running WSL. I have not tried, but if you have an Ubuntu VM, you
Yeah.
can definitely do that.
No, within WSL, Ubuntu is OS. It's working. Okay, but the thing is, what are the extra stuff that I should have to have this ingress configured?
Okay. So if you don't mind, I'll share again. Okay, I can tell you what you can do at a very high level. Let me just reshare my screen with one of the example. Want to reshare my screen. Yeah. So the way you can do it in your Ubuntu system. So this is your Ubuntu system. And of course, you can deploy the Ingress controller on this. So basically, they're going to be an Ingress controller namespace. I'll just say that Ingress namespace, Ingress controller namespace. Now, what you can do is while deploying this Ingress controller, I'll just go to the Nginx Ingress controller. Might have, yeah, here. And there you can find different deployment methods as it is in the documentation here. Now, as you say that you want to do it locally, right? You want to do it locally. So assume that, I mean, you can see that, okay, doing on the bare metal. That's something which you can look forward to. And, okay, so I think there's a better way. This is also one approach. But, oh no, this is... yeah, one way, of course, what they are saying is, right, as you are deploying the Ingress controller, right, you can deploy Ingress controller as a type of node port. So this is the service of Ingress controller. And as you would deploy the Ingress controller as a type node port, what is going to happen is you are going to make your ingress. Sorry, I'm not sure the right screen. 1 minute. Sorry, I thought I'm doing the entire one. Let me reshare the entire screen. Yeah. So what I did is basically I went to the Ingress. I just searched on the internet about the Nginx Ingress controller GitHub, correct? And then I came to this particular site. The deployment portion is there, and here you can find different way of configuring the Ingress controller of Nginx. I went into the example of bare metal, and there is this particular YML file which can be used, which I have opened here. So now this Ingress controller get deployed as a regular application in your cluster, right? If you deploy the Ingress controller, it's going to deploy as a pod and as a service, right? And now you can do is you can expose that service as a type node port for your again playing purpose only. And here in this case, what you can do is you can say type node port, and then what will happen is your um, Ingress controller would be serving on, you can say as local host. I assume that you understood what node port service is, right? And now once it has been here, what you can do is then you can configure now that fan out paste method, right? The slash ABC and like that. Rather than configuring the name-based routing or the virtual host, you have to configure like this. And Mohammed has shared a link which you can check out how it can be done. That is one approach you can take it. The other approach is that you can basically run the Ingress controller. Again, if you, I'll just, it's an advanced thing, but if you can follow along, it will be really good. So what we can do further is we can run this Ingress controller pod in the same namespace of the host system or the Ubuntu VM what you have. And what I'm saying in this case, you would run the Ingress controller with the host network is equal to true option.
Okay.
And what happens in this case is your ingress now would be available on local host only on port 80, which is nothing but on the local host itself. Now you can use both kind of mappings. It can be the mapping of with respect to the path based, or it can be the virtual hosting based. So both would work in this case.
Okay.
Make sense?
I will give a try. Yeah. Yeah.
Yeah,
I will give a try. Thank you. Thank you. Thank you.
sure.
Sorry.
Anyone else want to mention any other point? Yeah, there's few more links are there which you can of course go and explore. Okay.
Yeah, that's correct. But just curious, buddy, like what are you using on WSL? Are you using Minikube, Docker Desktop? How did you set up your Kubernetes?
Yeah, I'm using kind cluster. Yeah.
Kind. Okay.
Yeah.
Okay, so you basically create Ubuntu and in that you run the kind, is it?
Yeah. Within that. Yeah. Yeah.
Okay, so I think, I mean, if you do, I mean, what I suggested you use Docker Desktop. That would be the easiest, or running it directly on the Windows itself. So if you're using Docker,
Okay.
Docker Desktop has integration of Kubernetes, and for playing purpose, it is really good, I believe. That would
Yeah, but I think it will support only one cluster. We cannot have multiple nodes.
yeah, I think yeah, that is there. That is there. So
Yeah.
you
Yeah.
need kind for that purpose. So
Yes.
kind
Yes.
would run
Yes.
directly on the Windows as well, right? Kind run directly on
Yes.
Windows,
Yes.
if I'm not wrong.
Yes. Yes.
Yes, you can try that.
Yes. I will do that.
Okay.
Thank you. Thank you for the
Okay.
reference also. Others also have given me. Thank you. Thank you.
Great. Okay. So let's get back. Okay. Let me just open my notes. So now the next point we were discussing about what are the different ingress traffic patterns what we so one is the primary one is the proxying of HTTP, which is like what is already mentioned is bread and butter for the ingress. This is like must to have, right? So you have the kind ingress, and then you can access the give a of course the ingress name, give a host you want to access, the path, like on which path you want to access, and the given service name. That is something which is very much clear, right? Then you can also do the HTTP proxying with TLS. Now, the idea here is when we want to expose our applications publicly, we would want to expose them with the HTTPS connection. So there are two ways of doing it. One is all the traffic from your client hitting the Ingress controller, and that particular connection is secure, HTTPS aware. And from that particular your Ingress controller pod, it would go to the actual application pod, and that can be unencrypted. So we are saying that we just want to uh, terminate the SSL at the Ingress controller level, and that is what has been mentioned here. So what happens in this case is we are going to configure a TLS. Uh, so basically in the Ingress object, you can see the spec and there is this TLS, right? And then what we are doing is we are going to create a secret. So secret, I think we're going to cover in the next section of this book. But a secret is nothing but your credentials, right? So here we can have the credential created with the private keys and so on. And that can be created for a given domain name, what we have here. And this can be configured at the Ingress level. And so what traffic is going to come, it will go to encrypted, but after that it's going to be unencrypted there. That is something which has been mentioned here, that your client accesses the website by a load balancer. You come to the Ingress controller pod where you terminate the SSL, and then send the HTTP connection to the pod, which is HTTP, not HTTPS here. Correct? That is what we mentioned in this case. Any questions here? Okay. We can also basically encrypt the connection between our controller and the pod, but not recommended because first of all you are internal to the cluster, and then it can become sometimes challenging as you configure it. One approach in that case, what you can take it, rather than saying that, rather than terminating the SSL connection to your Ingress controller, we can do a pass-through configuration. So pass-through is mentioned somewhere below in the thing. Let's just go there and see. Yeah, this is a pass-through connection. So what we are saying, our Ingress controller just does the pass-through of the connection, and the TLS terminates at the application level itself. That way I can also configure. That is one more approach I can follow. Now, I think this book does not talk about, this book is a bit old. I mean, of course, it's like 2021 thing, but as you know that, right, we can now support different Ingress controllers. So all the examples here in this book has been given with assuming that you have one Ingress controller and it works. But in practical, we may have multiple Ingress controllers, and how we are going to manage them, we are going to use them something called as Ingress classes. Has anybody used Ingress classes? And what is the use case? I already mentioned, but just to clarify, if you have heard about it and if you have used it in your applications.
Yeah, I think there's a Nginx Ingress class when you use a Nginx controller.
Yeah, correct. That is true.
Correct.
That is
Yeah.
true. But in that
Yeah, I
case,
mean,
it is
basically, if you need more than one ingress, right? So let's say if you have a public ingress and a private ingress, I think in that case the class name would differ, right? Uh, so I think if I remember correctly, I used it when I was using the AWS load balancer controllers, and we had one public load balancer for all the public ingress, and we also had an internal load balancer, which was our internal ingress. And that's where we use these classes to basically group all these ingress objects within these two load balancer entities. Because if not, I guess the default behavior is it would create a new load balancer for every ingress object. But if you add this class meta detail, it clubs all the ingress objects for that particular class into a particular load balancer.
okay. There's more that actually anybody else want to highlight. Okay, so there are many examples of ingress controllers, like of course ALB being one, and Nginx we discussed already. Then traffic, then there is Kong and so on, right? So it may not be there that you have only one ingress controller deployed in the entire cluster. You can choose to have different ingress controller for different namespaces as well. Because see, if the cluster size is huge, right? One ingress controller cannot handle all the traffic, because as we know that it's going to update the proxy configuration all the time. And if you have a lot of endpoints, it can become challenging. So we may want to kind of, maybe we want to use two Nginx one only, but we want to give a different namespace base. For example, for prod and name dev, again, there are different namespaces there. So you can say that this controller is for my whatever, like uh, dev, others for QA and whatever. And these can be of different type as well. I can have one combination of Kong and of controller of Nginx as well. I can even choose to have different types as well. So the ingress class has been created to for that particular purpose only, that you can give a unique name to each ingress controller's configuration with the ingress class name. And when you're deploying different ingress objects, you can choose which one to use, and you can also configure one of them as default. So if you don't specify anything, it will come from there. But otherwise, you can define the ingress class as you would want.
There's a question from Mohammed Babili.
Yeah.
He's asking like, how would multiple hosts be served under the same load balancer service? Isn't one external IP for this load balancer service? I'm not sure.
Yeah.
Can you take that, Ikadra?
Yeah, sure. So, uh, see, one load balancer. So we are creating the load balancer for the ingress controller. Okay. So if you just give me, if you just allow me, right, I can share some of my slides which I have prepared earlier for one of my course, and that may kind of help you answer that. So let me just get that. One minute. Yeah, so that is the case that we are going to create one ingress controller, and that ingress controller is going to handle. I'll just get the slides. A minute. Yeah, so this is what I'm talking about already, right? We have the ingress controller and we have the different objects. So, but let me go to the slide here. Yeah, so this is how it would look like, right? When you deploy the ingress controller. So what is happening is, as you can see, we have deployed this ingress controller as an application, like a deployment or a daemon set. It would create a service, you create a service, and this would get deployed as a type load balancer. So we are deploying the load balancer for the ingress controller. Hope that makes sense. Now, for all of these websites like blue or the green and so on, right? We would map all of the DNS name to the same load balancer IP, correct? So when the traffic comes to all of any of these domains, right? All of them come to my load balancer of my ingress controller, which would send the traffic to my controller pod here. Okay. Now this controller pod would basically forward the traffic to my underlying pod of the blue or the green application. Make sense? So we are deploying the load balancer for only one of the controller here, the Ingress controller pod. So in the type load balancer service, you create one load balancer per service, correct? No, here is the same name, right? See, as I mentioned earlier, right? The DNS name cannot map to the combination of different IP and the port, correct? That is the problem what we have with the type node port, correct? Now, what we are doing here is we are mapping all of these DNS name to the same IP, correct? And whenever they hit that particular IP, it goes to my this particular pod, and then from the rest of the magic happens. Mohammed, am I making sense? Okay.
Okay, Nipendra,
Yeah.
I would
Go
just
ahead.
like to put it this way, and correct me if my understanding is wrong here. So, to answer his question, if I would simplify, even if we, let's say, forget about Ingress and everything, Kubernetes, right? If we just have one VM, right, a public VM with a public IP address, and we just have Nginx running inside that, okay, I can still point blue.example.com and green.example.com, these two different custom domain names, to the same IP address, which go to the
Correct.
machine. And at Nginx level, or let's say Apache web server level, I can have multiple virtual hosts defined in my
Correct.
configuration, right?
Yeah.
And there the Nginx will basically look at the header, the host header, which is blue or green. And based on that, it would send traffic to, let's say, port 3000 and port 5000 for
Correct.
these two
Yes.
different applications. And
Yeah.
essentially that exactly is what our Ingress is kind of doing
Yeah.
it for us. But in this case, we pass the configuration as YAMLs instead of dealing with the actual complex configurations of these underlying
Yeah.
servers. And also, I mean, the dynamic nature that you explained, right? IPs come and go. So all of that is kind of taken care of by the Ingress for
Correct.
us. We just
Yeah.
have to pass a YAML.
Correct. I think we discussed that point in the last session. So, yeah,
Yeah.
so maybe we can pause on the recording, and if you read the previous chapter book, it will become much more clear. Okay, great. So let's just carry on. Then we talked about a proxying of HTTP. Then we can do with the TLS as well. We talked about those things as well. And then we can also do layer 3 and the layer 4 based proxying as well. That is possible. So what is being discussed here is we can, so typically the Ingress are only supporting the connection of HTTP primarily, correct? But if you want to pass on the TCP thing, how we will do it? So what again example has been given for Contour, which I have not tried myself, but it is straightforward that what we are doing is we are kind of creating a mapping, saying that if we configure this kind HTTP proxy, and then we have the TCP proxy configuration inside it, correct? So what is happening is when the traffic is going to come to our Ingress controller, it is going to forward to the underlying app on the TCP port number. So we can have even these kind of mapping, which is pretty interesting, that you can use HTTP to kind of communicate with the TCP thing. That's something which is new for me to learn. So Contour can support that. So this is how it can be. It can support layer 3 and the layer 4 protocols as well, which is pretty interesting. Um, Now, the other point was how would you choose when you have multiple options available for the Ingress controller? The names mentioned here is, of course, Contour, HA proxy, traffic, Nginx controllers, Kong, and many more, right? So, which one to choose and when? So that again, the answer is depends, right? That's as usual. The answer is depends. So, but they have given some of the points to be considered when you are deploying the Ingress controller, which one to choose from. So whether it supports HTTPS or not, whether it can give you affinity of sessions or not, whether it can have different algorithms for the load balancing between the pods and so on, whether support of course or there or not. So all of these things you can consider when you are choosing a given ingress controller, correct? Um, then the other point was mentioned is what are the different deployment configuration you can do it. One is the sub option they have given is you can have dedicated nodes for the ingress nodes, which is very good option actually. So the idea is that other than having the ingress controller deployed on other nodes, we can dedicate certain number of nodes there, and these nodes can work only for the ingress controller. And we can even divide them if we have different racks. We can say on one rack this is a node for that purpose, another node, other rack as well, one of the node. That way we can kind of again achieve fault tolerance there. And of course, the resource will not be shared between the controller nodes and the regular machines resources there. And in some cases, when you configure the external traffic to come inside the cluster, you can just basically allow them to go inside a certain number of nodes. So I think you can have restricted firewall policy to allow only those nodes to talk to the external world, and then that would kind of be much more isolation than the other one where you deploy the controllers on the other nodes as well. And the point of what I was mentioning earlier, right, that we can also deploy the controller on the host network as well. In that case, your controller runs directly on the port 80 of your machine. So yeah, and then the other important point here was the DNS, the role, DNS and its role in the ingress, right? So as we discussed here, right, when we configure these ingress objects, right, we are giving the name here of the host, right? Like as you can see here, it has been given app.example.com. Now what I can also do is I can say star.example.com kind of stuff as well. So basically I can have all of the request coming from any subdomain, right, land into this particular uh, application. That's one. Second is, and of course, when I'm configuring the TLS as well, right, I don't have to kind of configure TLS for different hosts. I can configure the TLS once for all the hosts what I have in the environment. So like blue, green, whatever you have, all of them can have the same mapping um, of the TLS. So that way you are not kind of right split a TLS for each and every one. So that can be very useful there. And then what we can also do is we can configure the creation of HTTPS based on the host names as well. So then if you have the what do you call, say, the star, we can also configure per host. So as we create different ingress objects, we can create the HTTPS for each one of them on the fly. And that is possible with the help of software called Cert Manager. Has anybody used Cert Manager before?
Yes.
Yeah, I have used.
Okay, so the basic principle is that what you want to achieve here is you want to achieve that whenever we are creating the ingress object, I should also be able to create the TLS for that, right? And this cert manager can help me achieve this. This cert manager we can have, of course, with our some kind of private one as well, but we can have used with the Let's Encrypt. So I hope all of you know what Let's Encrypt is. It can generate certificates for you for your host name for free, right? Whatever the site name, whatever you have. So we can configure the cert manager with the Let's Encrypt configuration. So what you're seeing here is as we create the ingress object, and if we don't have the ingress created, the missing part, we will go to the cert manager, which would create certificate for us. All the things will happen, and then we will attach certificate to our ingress and continue forward from there. So I'll not go too much in detail right now here, but what I'm trying to convey here is there is cert manager which can automate all the process for you of generating these TLS or the credential, or you can say private key for your application to connect securely with the world on the fly. The other thing is also is when you create these different DNS name right on the fly. Now, how does these different DNS name like blue, green, yellow, whatever you create, right? So blue.example.com, green.example.com, and so on, right? So we have to have a respective DNS mappings as well on the cloud or on our DNS server. So there we can use the software like external DNS If you have used it, I'm not sure. Have you used XML DNS earlier? Anyone?
Yes, I've used it.
Yeah. This particular software need to be used when you are creating these random names, right, on your ingress object. There has to be a respective mapping in a DNS. So this software can help us talk to that talk to that provider of DNS and add that entry on the fly. So you can either choose to have star, which can does for all the subdomains, or if you have a domain name which is coming at random, you can use this XML DNS to update your DNS provider on the fly. So again, very useful project, very interesting. I have used it and very useful in multiple cases there. Okay. Any other points you want to talk about Ingress? Okay, great. So the next one is the service mesh. So let me just get here. Yeah.
I have a quick question before we go. Just wonder if anybody else used this cert manager, anything else besides the Let's Encrypt, because it's the only one I used, and it's I know it's free, but is there an API for other providers like CAs? Have anybody used it? Just wondering if there's experience.
No, I have not used it. Cert manager, we can only search one thing, right? Cert manager. Providers, right? I don't know.
It says Cloudflare has one, so may.
Yeah. Yeah, there are many of them are there. Yeah. Very sure, right? Yeah.
Okay.
These can be used. Okay, given the steps here, we have to just follow it, I believe. But yeah, because this will be very popular when it becomes very straightforward to kind of do it. So that's why I think everyone does like that, unless there's a requirement not to do that. Okay, so with that, we still have 10 minutes. I think we should go forward on this chapter, how much we can, and maybe extend 5 minutes more if we can finish this, and then start the next the new chapter. That would be really helpful. So service mesh. So one of the biggest point what they have mentioned in this particular chapter is companies start using service mesh because it's very shiny, but eventually they might just use the Ingress thing for that. So it is kind of unless you know that when to use it, service mesh, don't just go and just implement it and then kind of try to make it work, right? So it's for the special use cases. So first of all, the attention being given here is that first figure out what is your use case, and if the service mesh actually fits it, then use it. Otherwise, please just stick with the solution which is much more simpler, like Ingress only. If you're just using for the Ingress communication, just stick with that. Why want to bother about the other feature which is being given by the service mesh? But being said that, it's not that it is not useful, but you should know when to use it, when not to use it. And I think they have mentioned already that when not to use service mesh. I think somewhere in the very beginning of the book itself, that please go over it to kind of get more details about it. But
Yeah,
the
he
main,
mentioned. Oh,
yeah,
sorry,
go
go
ahead.
ahead. Yeah, I
No,
was
no,
just
go
saying
ahead.
he was mentioning that it's important to have operational knowledge and understanding how what's the implications using service mesh for in your environment.
Yeah, correct, yes. So we have KU service mesh primarily for these purpose: routing and reliability, security and observability. So these are the features which are kind of given by any service mesh, like again Istio, Linkerd, and others, right? Whatever are there. Just make sure that you know why you want to service mesh, and then it's really useful. Then similar to the different interfaces, what we have like runtime, CRI, CNI, we also have service mesh interface, but it is not part of the Kubernetes itself. It is being developed outside the Kubernetes main code, you can say. But the idea is that it can support, if it's, I have not seen, to be honest, the SMI service mesh interface uses a lot. I mean, used a lot, but correct me if I'm wrong. That have you seen this being used very often in the industry? The SMI thing. Anybody has seen it? At least I have not come
No,
across
not directly, but I guess it's always via Istio or Linkerd or console or via some
that. But
implementation of it.
have it they are they using it inside? I have no clue at all as well. I think it's a
No,
layer on
not
top
really.
of it other than below. I don't think it is so why would Istio would ship the the configuration of SMI? But anyway, the point was that is we can have one kind of a like a CRG in the object using which we can kind of configure my traffic. For example, here I'm saying traffic split, and I'm saying that when the traffic lent to my website, 70% should serve by the version V1 and 30% version V2. That is what is mentioned here. So we can configure some of these SMIs, and of course, they will be implemented eventually by your given provider like Istio, Linkerd, and so on. But there can be one top level thing which can help us achieve that. That example is being given is, for example, if I want the communication to happen between two services, like for example, I want payment service to communicate only with the flight one, for example. I'm just giving a name here, but the point they're saying that I can help have these SMI configuration, and I can create these route groups, and the communication would happen in between those route groups only. So, for example, we talked about network policies earlier. The same thing has been configured here, that it should be configured like that group, and then we can say who can connect to whom and all that stuff. So, but I said that I have not seen the SMIs have been used a lot, so I'll not go too much in detail in this, but please feel free to explore it later. But the idea is that we have a kind of a standard configuration to kind of enable the split and all those things, and underlying whatever the network or whatever the service mesh you will use, it should implement that.
Looks like this service mesh interface project is archived.
Yeah, that's what it's kind of archived. There's no, I have not seen at all, but because as very difficult to kind of keep something outside and say people take it, right? So it's very difficult.
Yeah, yeah, and
Uh,
these service meshes, particularly the popular ones, they are businesses in themselves,
Correct.
right? They have their
Yeah.
own intentions, they have their own goals. So yeah, I mean,
Correct.
difficult.
Very
I remember
difficult.
there was a similar AWS was kind of leading this GitOps kind of merger between Flux and Argo CD, and they were creating this GitOps engine and
Uh,
they were trying to create a common interface. But I don't see that project also going anywhere. I guess that initiative is also kind of pretty much dead. Both of these projects
correct.
are kind of running independently.
Yes. I don't see much. Okay, so I think we have only 3 minutes left, I believe. So I think I thought we'll continue, but I think by looking at the envoy now, if I go into envoy and discuss, it would take more than half an hour for sure. But if you have not, and what if you not talk, so we'll talk about envoy a bit, and then basically you can. I would highly recommend that go and check it out what envoy you can do, and you can configure only with envoy. You can configure many different things. If you don't kind of rely on some of these high level service meshes, you can actually build everything with the envoy. So the biggest problem or challenge what Envoy has solved, that it can be configured on the fly, and it will not have a downtime if you reconfigure it. So what used to happen is all of these proxies or the whatever configuration you have for proxy what you have earlier, right, before this, they need to be reloaded by itself, right? So when you change something, you reload it, correct? And by doing the reload of it, what can happen is existing connections what you have, they may break for your clients. So that was a bit of a challenge. But Envoy solves that stuff. So you can configure this Envoy on the fly, and it can do a restart as well without dropping the packets what is coming from your clients, which is there. So that is the biggest thing what NY has solved, apart from giving you the different features which are there. So I think we'll touch upon this topic in the next session itself, and then if we finish this, then we will, of course, we'll finish next. I mean, 25 minutes I would think require for this particular service mesh part, and then we can move to the secrets thing. And if you will, it's perfectly fine as well.
Makes sense.
Okay, fine. So, guys, any comments, any feedback you have, the way we have to run this particular sessions and all those things, please have them coming, and please spread the word about the book club so that we have more volunteers, more people can share. So that's better for all of us.
Yeah, and there's also a Slack channel for those who are not there already.
Yeah, please do
On
share.
the
Yes.
CNCF. Yeah, I can. Let me just quickly share the link.
And it's this some book club, right? What is it?
Yeah, I'm just adding that. Yeah, so you can join Cloud Native Slack and join this Kubernetes book club.
Okay, and the recordings are there, I think, which we are not keeping track of it, at least for this particular EMEA session. So we would do that actually, that all of these recording what we are doing, they are in one place, so that you can always go and refer the previous ones as well. Any feedback, guys? Hope it was useful, worth of your time. And suggestions are most welcome. How we can make it better, interactive, and so on. Because 1 hour is less time, but we have to manage with this. Yeah. Okay. We are
Looks like you're doing a good job, Nitin.
okay. Yeah, we are doing a good job.